Okay, good day, my beautiful students. Still your boy Kossydgreat. Today, we are going to look into the tangential velocity, which is the velocity of this body at any point on a circle. Okay, so you can see the body may be here, the body may be here, the body may be here, it may be here. So any point we see the body, we are going to know the velocity of that body at that point. Okay, unlike what straight line where we have the same velocity, but this is a curve, the velocity varies. Okay, so because of that, now we are going to look at the tangential velocity, which is the velocity at any instant. Okay, now if you look at this, how do we get the velocity? One thing you should know is what, for you to get the velocity, you must first of all know the amplitude. Okay, and when you know the amplitude, you know the displacement of a body at that point. You can see this body is at this point. You can see the displacement from the origin, that is from the equilibrium point, from the center to that point. Look at the displacement. If this body is here now, the displacement will change, which means for you to calculate this velocity, you must be given the position of the body, which is the displacement from the center. Okay, now remember we said that x, which is the displacement, is given as what? A cos of what? Theta, where our theta is equal to what? Wt. Okay, now let's substitute. We are going to have that x is equal to what? A cos of this theta, which is this theta is equal to what? Wt. We start from here. Call this equation 1. Now we are looking at the velocity. That is what we are looking for. Okay, so since we are looking for the velocity, how can I get velocity from this equation 1? We are going to differentiate this displacement with respect to what? Time. Okay, so when you do that, we are going to have differentiate displacement with respect to time. You are going to see that dx dt will give us what? Velocity. That is change of displacement with respect to what? Time will give us what? Velocity. So we are going to differentiate this. How do we differentiate this? Bring this one outside. We are going to have WA. Okay? Differentiate cos. We are going to have minus of what? Sine. Now we are going to write this thing back. We are going to have WT. Why do we do that? Because in a function, when you are given that y equal to, maybe I have something like 3 sine of, or let me just say cos of what? 2t. You want to find the y dt. All you have to do is what? Keep your 3 constant here. Bring out these 2 outside. Multiply it with this 3. So differentiate cos. You are going to have sine of. So write this function back, which is what? 2t. So that this times this will give us 6. That 6 multiplied by this will give us minus 6 sine of what? 2t. That is how we do this kind of what? Differentiation. So that is what I did here. I brought this one outside, use it to multiply this, which is this. So differentiate cos, we have minus sine. We write the function back, which is what? Wt. So the v, the x over what? Dt, which is what? V, is equal to, multiply out, we are going to have minus of what? Wa sine of what? Wt. Okay, then this is for velocity. So velocity is equal to minus Wa, we have sine of what? Wt. This is for velocity. Okay, now how can I relate this velocity with what? Amplitude and what? Displacement. Now from here, I will say square this equation. Let me call this equation 2. Square the both side of the equation. To square the both side of what? The equation 2. We are going to have that what? V square is equal to minus of Wa sine of what? Wt all square. Okay, so when you now do that, what are we going to do? We are going to have that v squared is equal to minus of WA will be square and sine square WT. Okay, you can see this sine will be square. We have this. So if you want to find, let me just say I have sine theta. If you want to square this, we are going to say sine square theta. Okay, we don't do it this way. It's not sine theta square. No. So what do? We just put that square here. Okay, so because of that, I now put my square into this place. That is why we have what sine square WT. Okay, now after getting to this point, you will notice that what sine square theta plus what cos square theta is equal to 1 in mathematics. So because of this, remember that our theta now is what? Remember our theta is equal to what? WT. Okay? So which means we have sine square theta is what? WT plus cos square, what is theta? WT is equal to 1. Now, if we know this, that simply means that we are going to make sine the subject of the formula. We make sine squared the subject of the formula. If you make it the subject of the formula, you're going to have sine square WT is equal to 1 minus cos square WT. Okay? So that simply means that any place you see sine square WT, you call it this. Now, okay, now, having known this, what are we going to do? We are going to put it here where we have v square is equal to minus WA square is the same thing as what? WA all square into sine square WT. Sine square WT is what? 1 minus what? Cos square WT. Okay? Now, if you look at this, we are going to have this as what? This is the same thing as W and A amplitude are having square. So we have W square, we have W square, A square, okay? Into, what do we have? 1 minus cos of what? Square WT, okay? Now, V square is equal to, open up the bracket, this time this will give us what? W square, A square, minus, this multiply this will give us what? W square, A square, we now have cos of what? Square WT, okay? So V square is equal to, now if you look at this, let's factorize the angular velocity. This is W square, bring out what? One of it, we have W square into this, divide this will give us what? A square minus this, divide these people. We are left with what? A square cos of what? Square WT. Okay? So why are we doing that? We have that V square is equal to, we are doing that because look at this, A cos of WT. We have A cos of WT. So there is something we are seeing, which is the displacement. Now, we have W square into, we have what? A square minus, look at this. If x is equal to A cos of what? WT. But here, if I square this s now, if I square it, it means that I am squaring everything you have here, which is what? A square cos of what? Square WT. Okay? So you can see, if I square this s now, I will square this and square cos. Okay? Which will now result to this. That means that here, where we have A square cos of square WT is the same thing as what? S square. Because if I don't square it, I'm going to have x, okay? So I'm going to call the whole of this thing now S square. So finally, V is equal to square root of, we have W square into what? A square minus what? S square, okay? Now, remember that square root is all about plus or minus, okay? So finally, what are we going to do? We are going to have this to be equal to, what is common here is what? Okay, sorry. If you come here, you are going to see that what? Square root of w square is what? W, okay? So we have plus or minus, we have square root of what? What do we have inside? We have a square minus what? S square, okay? So this implies that the velocity is equal to W plus or minus, we have square root of what? A square minus what? S square, okay? So when do we use this formula? We use this formula whenever we are given the amplitude of the motion, which is the maximum displacement of this what? Body. And again, we are also given the displacement. Displacement means the position, the point at which the body is what? The velocity is what? Taking. You can see, I can say that this body is what? 5 cm from the center, 2 cm from the origin, 3 cm from the center. You understand? We are given the position of this body, okay? Where we are going to calculate the what? The velocity. Why this is the angular velocity. Thank you. See you in the next video.